Hi, everyone. We're now going to go from identities number 10 and 11, which are two specialized double angle identities for cosine, and we're going to get these PRIs, the power reducing identities. By the way, some books actually switch the titles on these. Try not to get confused by that, between the PRIs and half angle. I call these the power reducing identities because they have a key purpose of reducing the power on an expression. So in calculus, remember that calculus hates squares. Calculus hates taking the derivative or an integral of a square, like the square of sine of u, or the square of cosine of u, or the square of tangent of u. So we might want to break this up. Now, these right-hand sides might look worse, but actually calculus loves these when it comes to taking derivatives or integrals, differentiation or integration. Okay, so how do we get these power reducing identities, these PRIs? And again, they're power reducing because on the left-hand side we have squares. On the right-hand side, we don't have any squares. We do double the arguments, and in some ways the expression gets more complicated, but at least we don't have squares. Calculus hates squares. When you're integrating, you're going to have to rewrite this as that. I suppose it's possible to go right to left, but it's much more common to go left to right. Okay, now, first of all, a nice way to memorize these, it's good to memorize that sine squared of u is 1 minus cosine of 2u all over 2, or you could break it up. Break up the fraction term by term like that. How is the cosine squared of u identity different? There's only one difference. It's that plus sign. In fact, there's a cute little mnemonic I use. Sin is bad. That is, sin is negative. That's kind of a theological comment, and it may not apply in Vegas in normal days, but we often associate sine with the negative sign. And we're going to see that. Very often when we're dealing with sine, there's a negative sign involved in the corresponding identity. Whereas the cosine version, or in this case, the cosine square version, will have the plus sign. How can we get a PRI for tangent squared of u? Well, here's a variation on the quotient identity. Tangent squared of u is sine squared of u over cosine squared of u. Okay. So it's going to be this fraction over this fraction. Basically, the little 2's die out. You can multiply by 2 over 2, and the little 2's die out, and you end up with the top of this guy over the top of this guy. 1 minus cosine of 2u over 1 plus cosine of 2u. Again, sin is bad, sin is negative. You remember the minus sign is on the top, corresponding to this sine square guy. So these are ways of remembering the PRIs, the power reducing identities. How do we get them? How do we derive them? Well, let's look at these derivations. We get them from these two special versions for the double angle identity for cosine, cosine of 2u. Remember, we applied the Pythagorean identity in different ways to get this and to get that. All right, so how do we derive the PRIs? So for example, here is identity number 10. Identity number 10, okay? It was one of our specialized double angle identities for cosine. Cosine of 2u equals 1 minus 2 sine squared of u. Now we're going to solve for sine squared of u. So we can add 2 sine squared of u to both sides. At the same time, subtract cosine of 2u. So we have a minus sign over here. And then to solve for sine squared of u, divide by 2 on both sides. Sine squared of u equals this fraction over here. 1 minus cosine of 2u all over 2. And then again, it's easy to remember that you flip from minus to plus to get the PRI for cosine squared u. If you do the work, it's even easier. You add 1. Here I switch sides. You add 1 to both sides, divide by 2. It's even more straightforward. It helps that the cosine guy is in front. And by the way, the idea that sin was bad, sin was negative, that helped even with number 10 and number 11. Remember that for number 10, the minus sign is in front of this 2 sine squared of u term. Whereas for number 11, this guy over here, there was a plus sign basically in front of 2 cosine squared of u. So right there you could see how we associate the sine version with a negative sign, the cosine version with a plus sign. The PRIs for sine squared of u, cosine squared of u, and tangent squared of u, because calculus hates squares, especially when you're taking integrals. When you're integrating, you rewrite these like these. Okay, next up. So we have now numbers 12, 13, and 14, right? Numbers 12, 13, and 14. This is number 12 for sine squared of u, 13 for cosine squared of u, 14 for tangent squared of u, if you want to keep track. So now from these, we're going to get 5 half angle identities, and that's next time.